7.4, being argumentative. Objective 1. Let's identify the differences between a valid argument and a fallacy. A logical argument consists of two parts, a set of premises and a conclusion based on those premises. Premises are statements that are offered as supporting evidence for the conclusion. Our goal is to decide whether an argument is valid or invalid. An argument is valid if the conclusion necessarily follows from the premises, and invalid if it is not valid. An error in reasoning that leads to an invalid argument is known as a fallacy. Logic is not about deciding if a claim is true. It is about deciding if the claim can be deduced from the given premises. So example 1. Premise 1. All students in this class will pass. Premise 2. Rachel is a student in the class. Conclusion. Rachel will pass the class. A. What are we told about who will pass this class in premise 1? B. Is Rachel a student of the class? And C. What can we say about the validity of the conclusion? Why? So premise 1 states that all students in the class will pass. This means all means every person who is a student in this particular class is guaranteed to pass. B. Is Rachel a student? Yeah. Premise 2 told us that Rachel is a student and she is confirmed to be a student in the class. So the conclusion follows logically from the premises. If we accept that all students in the class will pass and Rachel is indeed a student of the class, because we know that, since the premises assert that every student in the class passes and Rachel is one of those students, it logically follows that Rachel will pass the class. So let's use truth tables to evaluate the validity of arguments. First, we write the argument in symbols, right? That's what we always do. Then we write the argument as a conditional statement using conjunction between all premises and the implication for the conclusion. Note that that arrow means the same thing as just a regular arrow. We set up and construct a truth table with symbols, premise, and premise conclusion. If all the values under the conclusion or under the if-then statement are true, then the statement is the last column is a tautology, then the argument is valid. Otherwise, it is invalid. So for an argument to be valid, it needs to be a tautology. And I'm going to explain the step 2 and 3 better. First, let's go ahead and tackle example 2 and then we'll explain it as we go. If the ad campaign is a success, the marketing manager won't lose her job. The marketing manager lost her job, therefore the ad campaign wasn't a success. Alright, so a premise is separated by a period. So there's a period, and there's a period. So our first premise is if the ad campaign is a success, so we're going to say that's P. And then we have if the. If the is the same thing as saying if then. We have the marketing manager won't lose her job, so that's going to be negation Q. Since we have a period, we go to the next line. This is what we call premise 1. Alright, so the next line, we have the marketing manager lost her job. That has to do with Q. The marketing manager losing her job is Q. We have another period in the word therefore. So since we have another period in the word therefore, we know to go to the next line. So this is what we call premise 2. Therefore means this. Therefore, the ad campaign wasn't a success. So the ad campaign, that had to do with P, but since we're saying it wasn't a success, that's negation P. So in between premises, we put and. So we have our first premise. We're going to label that pink. So we have P, if then negation Q. And then in between each premise, we put and. And then we have another premise, which is just Q. So we don't need to parentheses it, it's just Q. Put that in blue. And then the conclusion, the therefore, that's a conditional statement. So we set the condition, and then we have negation P. So we're going to group together our premises. All right, let's do our truth table. We have P, if then, negation Q. We have and. In between each premise, we put an and. Then we have Q. And we're going to block those together again. And then we have our conditional statement and negation P. So brackets, we treat them like parentheses, so we're going to work inside those first. All right, so inside our brackets, we have a parenthesis. So 1, 2, connector last. We look outside the parenthesis. We have the Q. Then we're going to bring it together with our connector. Outside our brackets, we have a negation P. And then last but not least, we have our connector. So 5 and 6 are going to give us 7. So for P, we just rewrite P for exactly what it is. So that's true, true, false, false. For negation Q, we do the opposite. So that's going to be false, true, false, true. And then we bring it together with our if-then. So TF is the only thing we care about. So TF, well, that's false. TT, that's true. FF is true. FT, that's true. All right, let's fill out Q. It's just normal Q, so TF, TF. And then we're going to bring it together with an AND. So for AND, we need both to be true. So we have false, true, that's false. True, false, that's false. True, true, that's true. And true, false, that's false. All right, so now the brackets are simplified with the purple. The brackets, nothing else matters except the purple. Now we negate P, so false, false, true, true. And let's bring it together. So we're going to be looking at the green and the purple. We have F, then F, that's true. F, then F, that's true. True, then true, that's true. False and true, that's true. So since our answer column is all T, this is valid. This is a valid argument because we have a tautology. If you need to see another example of this, go to Canvas in this chapter, and I have more videos for you. You can find those videos, you can get more practice. They're from a different class, but it's the same concept. It's literally the same concepts. Everything you're doing is the same. It's just more examples. All right, determine the validity of common argument forms. So there's certain common argument forms that just work, and we've proven them time and time again of how we argue, and these are the most common ones. And then we have the fallacies. You do not have to memorize these. You will be given this side of things. You're going to be given this side of things. So we have law of detachment, that's P if then Q. P, therefore Q. So an example of that is if our team wins Saturday, then they go to a bowl game. Our team won Saturday, therefore our team goes to the bowl game. Law of contraposition, P if then Q, negation Q, therefore negation P. If I try hard, I will get an A. I didn't get an A, therefore I didn't try hard. Law of syllogism, P if then Q, Q if then R, therefore P if then R. If I make an illegal U-turn, I'll get a ticket. If I get a ticket, I'll get points on my driving record. Therefore, if I make an illegal U-turn, I'll get points on my driving record. Law of disjunctive syllogism, P or Q, negation P, therefore Q. My top client demands the penthouse or an executive suite. He couldn't stay in the penthouse, therefore he stayed in the executive suite. So those are all valid arguments. Now there's fallacies as well. P, the fallacy of the converse, P if then Q, Q, therefore P. If it is Friday, then I'll go to happy hour. I'm at happy hour, therefore it must be Friday. That's actually a fallacy. Fallacy of the inverse. P if then Q, negation P, therefore negation Q. If I exercise every day, then I will lose weight. I don't exercise every day, therefore I won't lose weight. That's a fallacy because you can lose weight otherwise. Fallacy of the inclusive or. P or Q, P, therefore negation Q. If I'm sorry. I'm going to take chemistry or physics. I signed up for chemistry, therefore I'm not taking physics. Let's determine the validity of an argument. We're not going to use a truth table, we're actually just going to use our laws. So we have, if you have enough reward points, then you get a free flight. You do not get a free flight, therefore you do not have enough reward points. That comes out to P if then Q, negation Q, therefore negation P. That follows the law of contraposition. So if you come out and make your premises and conclusion and they match a law or a fallacy, you can absolutely say valid or invalid based off of that law. If you are on Instagram, then you see my pictures. If you see my pictures, then you know I have a dog. Therefore, if you are on Instagram, then you know I have a dog. So that comes out to P if then Q, Q if then R, therefore P if then R. That is valid because the law of syllogism. You're going to find if you need more support through 7.4, in those extra videos on Canvas that I put more videos, it's going to be sections 3.4 and 3.5. Let's determine whether it's valid or invalid. So if it is snowing, then we put salt on the driveway. We put salt on the driveway, therefore it is snowing. So that comes out to P if then Q, Q, therefore P. That's invalid because that follows the fallacy of the inverse.